Hello everyone, welcome to the video series on Hello World of Machine Learning using scikit-learn. This is chapter 4 of the series, and in this particular video we are going to look into how to split available data in training set and testing set. Just as a recommendation guys, these chapters are made in a sequence and I'll highly recommend you to go ahead and look into chapter 0, 1, 2 and 3. It will help you to understand what's going on in this particular chapter in a much better way. So here is what we are going to look into in this particular chapter. What is the need of splitting the data into training set and test set, and how scikit-learn can help us in doing that particular splitting. So let's go ahead and open our Jupyter notebook and play with it. Welcome to the Jupyter notebook of chapter 4, splitting training data into training set and test set. Whenever we train our machine learning model with some set of data, it will perform extremely well on that particular data, obviously because the training is done on those data. Unfortunately, we cannot judge our model based on the output on the training data because it will always be a perfect data, and we would not like to just publish our model to the outside world based on training data. To achieve the same thing, we generally do what we call splitting of training data into training set and test set, where we will keep aside some set of data from the training set for testing purpose once the model is trained. And then based on the output from the test set, we can judge how well the model is performing. Fortunately, scikit-learn also provides a very simple way of splitting the data into training data and test data. We will use a function called train test split, which is available in scikit-learn.model. And let me just go ahead and import train test split. Okay. Now this function train test split actually produces 4 output. These 4 output are xtrain and xtest, ytrain and ytest. As the name implies, we will be training our data on xtrain and ytrain. These are nothing but the training features and training labels, and xtest and ytest, these are nothing but testing features and testing labels. That's the way it divides the data. So we have already generated a data in our earlier chapter which called agri feature and agri label, and this data is all about point of sale of agricultural product from the farmer's place and what the respective price of it at a particular location. Now I will pass this data in this function called train test split, and I will get xtrain, xtest, ytrain and ytest. In this particular function, I will provide agri feature and agri label, and I say that test size is 0.40, which means that I want 60% of data to be used for training and 40% of data to be kept aside for testing. Since our test sample has only 5 items, this means that 3 items will be used for training and 2 items will be kept for testing. And you can see that xtrain and ytrain contains 3 features and 3 values. Okay, and the test will contains 2 features and 2 value, and we can play with this number to change the ratio of training and test data. Now how will we use this training and test data? It's very simple. Let's train the model first using linear regression. So I'll just create the instance of linear regression and I call the fit function with training data, and then let's predict the output, predicting the output by passing test data in it. This is the output which I got. Now the question arises that is this the output which I am expected to get? Well, you need to compare the results with available label. The available label is ytest. You can do it manually, but scikit-learn, as beautiful as it is, it provides a very simple way of checking the model. It is called score of the model. So the score provides me accuracy of approximately 77%. That's not a very good value, but good enough to understand what we are trying to do with test train split. In this particular case, this algorithm, linear regression, with this training set managed to provide 77% accuracy. So every time you go ahead and call this function, you may not get the exact training set because training set will be picked up randomly. So don't just expect to get this values as a training set all the time. Now let's use our another algorithm called KNN, okay, which we have already learned in chapter 2. So I created an instance of KNN with neighbor equal to 1. I am fitting this data xtrain, ytrain. I am predicting xtest and I have to compare with y test. Since I have only two value, I can actually compare individually. We know that none of them are matching. So let's see what's the test score will be. Test score will be 0. Unfortunately, this is very bad, but this is just to show you how it works. And in this particular data set, we will never gonna get more than 0 for test data, because each data has a unique data point associated with it, which is not duplicated. Okay, it is not clustered into a group. So in case if I just go ahead and check the data with the training set itself, I'll get the accuracy of 1. Okay, this was just to show you how you can use this particular train test split and use the score to evaluate the model. So in this particular case, linear regression seems to be the better algorithm with the data set. So similarly with scikit-learn, with all the algorithms, we are going to do the same thing, and at the end of it, you are going to pick up the algorithm which has better score. So that's all about this particular video, guys. Thanks a lot. Thanks for watching. See you in next video.